Hi everyone, this is Emily and welcome back to Java Lessons. In this lesson, we'll be going over logical operators, methods, and then you'll have worksheets and a project at the end to wrap everything up. And as always, links will be provided, and I will be using JDoodle, which you can also use to follow along and work on your project.
So last lesson we went over if-else statements and relational operators, which allowed us to make simple comparisons. And now we're introducing logical operators, which will allow you to do a lot more with if-else statements and make some more complicated statements. So first up, we have these two and signs right here together. We call that a logical and that kind of does what you might think it does. So logical operators allow us to just make our basic relational operators a little bit more complicated. So in the case of the logical and, it lets us string things together. So in this first example, we have two variables, numcats and numdogs. If numcats is greater than or equal to 6 and numdogs is greater than 7, it will print that statement out. So this will only print out if both of those things are true. So for a logical and to be satisfied, both things have to be true. Now, moving on to a logical or, which are these two pipes right here, which are just the vertical lines. A logical or also kind of makes sense in what it does. So in our example, if numcats is greater than 8 or numdogs is equal to 5, it will print out pets. So for a logical or, we need at least one of the conditions to be satisfied. So either numcats has to be greater than 8 or numdogs has to be equal to 5, or both can be true as well for that to be satisfied. And then finally, we have the exclamation point, which is a logical not. So a logical not is a little bit more confusing, but not really. So that just reverses whatever's in parentheses. So in this example here, if, and then we have in the not statement, 15 is greater than 10. So without that exclamation mark, 15 would be greater than 10, and this would print out. But because we are reversing it, we can basically read this as if 15 is not greater than 10, then print this out. So 15 is greater than 10, so this will not print because we are taking the opposite of what it says. So if we go on to JDoodle here and take a quick example, we have two variables, pens and pencils, and we have this if statement right here. If pens is greater than 5 and pencils is greater than 5, it will print out. So take a guess as to whether or not this will print. And you'll see that nothing prints because only one of these things is satisfied, since pens 7 is greater than 5, but pencils 3 is not greater than 5. And if we change this to a logical or, which again are those pipes, you'll see that it does print out because we only need one of these things to be true. And we see here that pens is greater than 5. So it doesn't matter if pencils is greater than 5. And finally, we have our logical not, which again, we just place whatever we're reversing in parentheses here, and you use the exclamation mark. So take a guess if this will print or not. And you'll see that nothing prints because our statement here is pens is greater than 5. So what we really have is if pens is not greater than 5, print out. And because pens is 7, which is greater than 5, then nothing prints out. Now you'll notice that in my previous examples, I could have done, maybe you might think, something like if pens and pencils are greater than 5. And you'll see that this returns an error because in Java, you cannot use logical operators to string variables together. You can only string these comparisons together. So like in all these examples, you'll see that the and always falls between two comparisons. So moving on to methods. Methods are useful in Java programs where you might be doing the same thing over and over again. So for this example of print inventory, let's say you have a company and every day you have to print out your inventory. So you have to print out the number of desks, chairs, tables, and doors. And you repeat this process every day. So you don't want to do this for every single time that you have to print out these lines. You don't want to just copy and paste that in your code. Number one, because it clutters up your code, and number two, because there's a much more efficient way to do it that's more organized. So you'll see here that we have this, what we call a method, which is just basically a chunk of code that you can run over and over again easily.
These blocks of code go inside something called a class, which is just a program with methods and variables in it. These classes can actually interact with each other, but we won't be getting into that today.
So you'll see here, the way we declare a method is with these words. So public, static, void, and then print inventory. And you'll notice these parentheses as well as the brackets. So everything inside the brackets is part of this method. So first of all, this word print inventory right here, that's just the name of your method. So you can change that to whatever you want, sort of like a variable. And we generally name those intuitively so we can kind of tell what is going to be in the method. So our first word here, public. Public is a word that kind of tells you where you can access your method from. So generally we either have methods be either public or private. If a method is public, that means that you can access it throughout your entire project. And this is more applicable for more complicated Java projects where you might have multiple files. And you might want to access a method from another file, which is just another Java document. So normally we keep this public just to keep things simple. Moving on to static. For now, we don't really have to worry about static because that gets into more object-oriented programming that we'll touch on in the future. And then void is what we call a return type. So methods have the ability to return something. And in this case, when we have the word void, it means that we're not returning anything. So what does that mean? When Java methods return something, that means you're spitting something back out from the method. So you might look at this and say, well, this should have a return because we're returning these lines to the console. And while it might seem like that, what we actually call a return in Java is different from just returning something in general, because these lines print out to the console, but we can't take these lines and access them somewhere else. So you'll see later in an example of something that does return. So here we have a method called enough money. And right off the bat, we see two things are different just in our declaration of the method. So first of all, we have this word Boolean here, where previously it was the word void. So this method actually does return something. It returns a Boolean value, which you'll remember is true or false. And if we look at our actual code, you'll see that what happens is we have if cash is greater than 20, return true, else return false. So the key difference here is that we have this word return. So this is what I meant when I said in Java, returning means something specific. This method will always return a Boolean value of either true or false. And that just means that if you run this method, like we'll see in a later example, you'll be able to use what it returns. Whereas in the previous example, it would just print out and you would not be able to use that. And now the second thing we see here is, whereas these parentheses were blank in our last example, here we have int cache within the parentheses. So that's what we call a parameter, which essentially is something that you pass into a method. So we can think of returns, in this example, the Boolean, as the output of a method, and the parameter, which in this case is int cache, as the input. So that's what you're putting into the method. So in this example of print inventory, we don't have anything inputted into the method. So that just means that you can run print inventory without putting anything in. In this example, we would already have num desks, num chairs, num tables, and num doors declared. So that would just print out the same thing whenever you call print inventory. But for this example of enough money, you might call it like we see here on the second line. So you see that we say the name of the method. So for example, of print inventory, we would just say print inventory, and that just calls the method, and that just runs the code of your method. And you'll see that there's nothing in the parentheses, but then on the example on the second line here of enough money, you see that within those parentheses, there's a number 23. Now, if we go back to our enough money method, that corresponds to the word int cache here. So what that basically means is we're setting int cache to 23. So just like you would declare a variable, you could think of this as int cache equals 23. So if we plug that into this method, if we replace all the caches with the number 23, just like with any variable, what we really have is if 23 is greater than or equal to 20, return true, else return false. So because 23 is greater than or equal to 20, this would return true. And what that statement return true really means, we can see here. So one way you can use a return type is like we see here with Boolean demonstrate return types equals enough money 23. So you'll remember that the way we declare variables is if we just wanted to declare a variable called demonstrate return types, it's a Boolean, we would say Boolean demonstrate return types equals either true or false. But instead of that true or false, we see here we have enough money 23. So remember we said that that returns true. So we can just replace this right here with true because that's what this returns. So Boolean demonstrate return types equals true because enough money 23 returns true. Now, another way you can use the same idea of methods is this example here. If enough money parentheses 15 equals true, and then we just have a simple system print statement, else print something else. And doing the same thing that we did above, if enough money parentheses 15, so we'll replace int cache with 15, so int cache equals 15, and we'll see that this returns false because 15 is not greater than or equal to 20. So if that returns false, then we can see here what we have is if false equals true, which obviously is false. So it will print out, sorry, you don't have enough for this item. Now, more specifically on parameters, you'll see here that we just have this generic method called test, and then our double here is just called this is a parameter. So that's just a general instance of what a parameter is. And you'll see that when we have parameters, we will use them somehow within the method. So in this example, we would print out the value of this parameter is, and then whatever we set that value to. Now in Java, you are able to have as many parameters as you want on a method, and you just do that simply with commas. So for example, if I want double, this is a parameter, but I also want int score, I would just do double, this is a parameter, and then a comma, and then int score. So you would just do as many as you want and just separate them with commas. So just a couple quick things to note about methods in Java. So first of all, when we look at our return types, you'll notice that when we do have a method that returns something, it will always return something. So in this example here, if cache is greater than or equal to 20, return true, else return false. So there's no condition where nothing gets returned. So if we have a return type, then something always has to be returned. Otherwise, you'll see an error. Now, we also want to note that in Java, a method will keep running until it hits the return statement if there is a return type. And then finally, you are able to call one method from inside another method. So this can make things a lot more efficient and a lot more quick and a lot more organized in your code. So now let's look at one last example of a method just to tie everything together. We have a method called test2, and take a look at how many parameters we have and what types they are and what this code might do. So the first thing you might notice is that the return type is void, which means nothing gets returned. So in this method, what we're doing is taking two parameters, a double for temperature and a Boolean for if it's summer or not. And then those are passed into this method when it's called. And then we just print out the temperature is whatever we passed as double temp. And then if summer, which is our Boolean, equals true, then system print out it's summer. So that wraps it up for this lesson. For our project, we are making a program to check if people can ride a roller coaster and if they can receive a fast pass. So in this project, you'll be working with everything that we covered in this lesson, so logical operators and methods. So first you want to make variables called name, age, and group size, which is the number of people in your group, so the number of people you're going with, and then height, and we can just assume height is in inches. If you want, as always, comment your code just so we know what is going on. So you're going to use the console to ask the user to enter a name, a height, and an age, which you would set equal to those variables. And then you would make two methods, one called canRide and one called fastPass. So canRide will return true if the height is above 48, again in inches, and age is above 13. And then fastPass will return true if the group has less than or equal to 2 people or your age is below 7. So again, those are our parameters that we set before, and you want to pass these as parameters into the methods. So you want to print out a message to the console letting the user know what they can or can't do. So for instance, if canRide returns true but fastpass returns false, for someone named Jake, you can print something like, Jake, you're allowed to ride this roller coaster, but you cannot have a fastpass. So here are the links for our worksheets and our answer keys, as well as the notes document for this lesson. So just go to tiny.cc and then Java capital L3 and then WS or WSAK if you want the worksheet or answer key. And that wraps it up for this lesson. Thanks for listening.